Now I can make my sign diagram. So I have -4, 2, and 6. That's where these equal 0. So pick any number over here. Say I pick -5. So -5. -5 cubed is -125. -5 squared would be 25 times -4, be -100. Minus 20 times -5 will be +100. And then we'll go with this, plus 48. So these will cancel out, and I still have more negative. So this area is negative. Between -4 and 2, let's pick 0. 0 cubed minus 4 times 0 squared minus 20 times 0 plus 48. So this is a positive. Between 2 and 6, I'm going to pick 5 again because I've already done some of that work. 5 cubed is 125. 5 squared, 25, times -4, be -100. -20 times 5 would be -100 again. And +48. I am doing, this is my step 1, so this is the one I'm checking. This being 173 and -20, so this is negative. And I'll go with the 7 over here. Try my 7. I checked 7 cubed is 343. 7 times 7 is 49 times -4, so it'll be -196. -20 times 7, -140, and then plus 48. Well, this is going to be -234. This is going to end up being a positive. So I want this to be less than or equal to 0. So less than 0 would be the negative areas. So from -infinity to -4, and that'll be a bracket because it's or equal, combined with the other negative place is from 2 to 6, and those will be brackets because it's or equal. The other way to say that would be x is less than or equal to -4, or 2 is less than or equal to x less than or equal to 6. Looking at the graph of it, and I did put this in for the graph, except this should be a positive. This point is -4, 0. This point is 2, 0. You can find these by finding the zeros, and this is 6, 0. And when we know when it's less than or equal to 0, so that's over here, where x is less than or equal to -4. Or over here, when 2 is less than or equal to x is less than or equal to 6. Remember, when you're doing it this way, you always have the smaller numbers first. To solve a rational inequality using the algebraic method, get the 0 on the right side of the inequality. Get a common denominator and combine the rational expressions on the left side. Find the numbers that make the numerator of the rational expression equal to 0 and those that make the denominator equal to 0. Of course, those are the sections where it would make the denominator equal to 0 will be where that rational inequality is undefined. Once you do that, you do a sign diagram again. That uses solutions from step 3 to divide the number line into intervals and do a test point and see if it's positive or negative. Note the points that make the denominator equal to 0 make the function undefined. And then identify the intervals that satisfy the inequality in step 1. The values of x that define those intervals are the solutions to the original inequality. So here's an inequality solved. We've already got it on one side equal to 0. I think the easiest way we want to get what makes the numerator 0. So x squared minus x minus 6 equals 0. Well, that factors into x minus 3 times x plus 2 equals 0. So x minus 3 equals 0. X equals 3. Or x plus 2 equals 0. X equals negative 2. So that's the numerator. And then having the denominator equal 0. X minus 6 equals 0. So x equals 6. Again, a sign diagram. So my points are negative 2, 3, and 6. And the 3 and 2 make the function equal 0, but the 6 makes it undefined. So I'm going to go a U there. Now remember, even though it's a boundary, we can't talk about that one, even if the rest it's or equal. We cannot use that. So checking a point, you'll have negative 3. So checking it, negative 3 would be 3 squared would be 9, minus a negative 3 will be a plus 3, minus 6, and then it'll be over negative 3 minus 6. That's going to give me a 6 divided by a negative 9, and that will be a negative. Between 2 and 3, let's do our standard 0. Checking the 0. 0 squared minus 0 minus 6. And 0 minus 6, so that equals a positive 1. Between 3 and 6, and we'll try 4. So 4 squared, 16, minus 4 minus 6 over 4 minus 6. That'll give me 6 over negative 2. That will be a negative. And then trying 7 over here. 7 squared would be 49 minus 7 minus 6. So that'll be a positive number. Over 7 minus 6. So that'll just be a 1. This is a positive. So it's a positive.